So the main topic is still the atoms, elements, and compound, but the subtopic, which is 3.2, it's about bonding and structure. So in this subtopic, you will study how the atoms are bonded with each other, different types of bonding, as well as the structure of the molecules or structure of the substance. So the first thing, the learning objective, describe the difference between element, mixture, and compound, and between the metal and the non-metal. So you should be able to distinguish the elements, the mixture, and the compound, or identify them or state the differences between them, as well as the difference between metal and non-metal. And then describe an alloy. You should be able to define or describe the structure of an alloy. And normally alloys are the mixture of the metal. So first, the definition of element, how we define element: a substance made from only one type of atom. So substance consists of atoms or group of atoms, but all the atoms are identical. When all the atoms are identical, what we call that? We call that substance as element. So example, if I draw the structures, and the question is identify which substance or substances are elements. So we have three different substances such as A, B, and C. What about A? Is it an element? Yes or no? The first string substance made up of one type of atoms. A is an element or no? That's the question. So yes, A is element. What about B? B is an element. What we can say about B? B is an element or no? Yes or no? B is also an element. Why B is also an element? Because it also consists of identical atoms. The term identical means same type of atoms. If same type of atoms are there, even they are joined together or even they are separated from each other, that substance is refers to an element. And what about C? C is not an element. Why C is not an element? Because two different types of substances are there, two different types of atoms are joined together. So C is not an element. Is it clear? The concept of element? So a substance that is made of only one type of atom, and these atoms might be joined with each other or they may not be joined with each other. But if it is single type of atoms or same type of atoms are there, we call that substance as an element. The second definition is about compound. So how we define a compound? A substance made from two or more elements that have reacted chemically. So a substance which is having two or more different types of atoms and they mix with each other or they reacted with each other, we call that substance as a compound. So example, again we have three different substances. So we have three different substances A, B and C. First one, A. Is A a compound? Yes or no? Is A a compound? So A is not a compound because A consists of different types of atoms, but they are not chemically joined together. So A is not a compound. What about B? Two different types of atoms and they are chemically joined together. So what we call B, is B a compound? So yes, B is a compound. What about C? Is C a compound? So C is not a compound because it consists of identical atoms. It must be two different atoms, and the second condition, they must be chemically joined together. So the second definition is for compound, that substance made from two or more elements that have chemically reacted or joined. And what about the mixture? The mixture consists of two or more elements or compound not chemically joined together. And chemical properties of each substance unchanged or does not change. So what is the example of a mixture? Like we have three different substances. First one, is A a mixture? The substance A. Is A a mixture? Yes or no? So that's right, A is a mixture. What about substance B? Is B a mixture? Mixture can have two or more different elements or it may have two or more different compound. We call that as a mixture. If we have different types of compound together, we also call that as a mixture. So you can see this is one compound, This is the second compound, and here is a third compound. So we have different types of compound together. So B is also a mixture. So two or more different types of compounds are there. Their molecules are different from each other. We also call them as a mixture. And same thing, you can see this is one compound. As you can see, this is one compound, this is another compound, and this is element. So when element and compounds are also together, we also call them as a mixture. So in this example, A, B, and C are the mixtures. What is A? A is actually a mixture of elements. What is B? B is actually a mixture of compounds. What about C? C is actually a mixture of element and compound. Is it clear? The concept of element, compound, and mixture. Any doubt till now? Any question or a doubt? How element is there? You can see it consists of, this is the element here. This is one particle, so element. Two different are there, so this is compound. Here also two different, so compound. So when we are working out how we can work out the difference between element, mixture, and compound. So elements having identical atoms, same type of atoms, we call them as element. A compound, when two or more or different types of atoms chemically join together, we call them as compound. So if we have different objects, or substances, first one is A. Identical atoms are there. What we call this substance A? Element, mixture, or compound? What is substance A? So substance A is element. And why we called it is an element? Because it contains identical atoms. Same way, if we have identical atoms, but they are joined together, combined with each other, but atoms are identical, atoms are same. So if identical atoms chemically join together, what we call that substance is also known as element. Why? Because identical atoms are there, so they might be chemically joined, may not be chemically joined, but we call that substance as element. What about compound? When different types of atoms chemically join together, and it can be two or more, but different types of atoms chemically joined. So what we call this substance? We call this substance as a compound, because there are different types of atoms and they are chemically mixed with each other. Then about D, if we have, this is one element and we have another element, but they are not chemically joined together, they are only mixed with each other, so that we call as a mixture, or we can simply say it is a mixture of elements. Like two elements are there, they are mixed with each other. Or we might have a mixture of compound. What is a mixture of a compound? If we have different types of molecules or different types of compounds, like this is one type and here is another type. So these are different types of compounds. They are mixed with each other. So when different types of compounds are mixed together, we also call that as a mixture. But this is actually a mixture of compounds. Is it clear now? The difference between the element, the mixture, and the compound. Any doubt in this? Then elements can be classified as metal and non-metal. So how we can identify the element? Actually, these are the classes of the element. When you have element, the element might be a metal or it might be a non-metal. But how you can identify whether the element which you have is a metal or non-metal? There's also one class which we call a metalloid. Few of the elements are there which we also call them as metalloid. Basically, how you can identify whether an element is a metal or a non-metal? By its physical properties, such as metals, they conduct electricity, they are good conductor of heat. Non-metals does not conduct electricity or not a good conductor of heat. Metals are hard, non-metals usually soft or brittle. Metals have high melting and boiling point, whereas non-metals have low melting and boiling point. But metalloid means some of the properties they have related or similar to metals, and some of the properties are related to or similar to non-metal. How you can identify? So you have to use a periodic table. In exam, you will have the periodic table. So using a periodic table, you can work out or you can identify whether an element or metal is whether the element is a metal or a non-metal. So first thing, what I want from everyone, what you will do, you will open the book and take out the periodic table or find the periodic table. The chapter 10 is about the periodic table. So when you check the periodic table, you can work out simply the region where you have metal and non-metal. How to work out a region? So first thing, when you check boron and aluminum, draw a stair. So draw stairs from boron to between boron and aluminum. So first what we did, because you can work out the element is a metal or a non-metal using a periodic table. So first draw the stairs between boron and aluminum. Now how to work out the elements on the left hand side of this stair are metals. The element on the right hand side of this stair are non-metals. So a simple technique is there. What you will do, between boron and aluminum, you will draw the stairs. And after drawing this stair, you can simply work out the position of the metal and non-metal. On the left hand side of this stair, you will find metals. On the right hand side, non-metal. So in a periodic table, you find most of the elements as metal, and very few of them are few non-metals, and very few of them are metalloids. So the shaded region, the part which I'm shading here in blue color, that is representing the metals. So what you will do, draw a stair from between boron and aluminium. On the left hand side, and this whole side, you will find the what I use a blue shade is representing the metals. And on the right hand side of this stair, it is representing the non-metal, which I'm using a pink shade to represent these non-metals. And as you can see, some of the elements I left here. Why I left these elements? These elements are known as metalloids. The one in a gray shade refers to metalloid. So basically, what are metalloids? Metalloids have properties. Some of the properties resemble or similar to metals. So on the left hand side, we have metals. On the right hand side, we have non-metals. And in between them, few elements are there: boron, silicon, germanium, arsenic, antimony, beryllium. These elements are known as metalloids. Metalloid means they have some properties resemble with metal and some properties resemble with non-metal, as they are between the metal and non-metal. Is it clear how you can identify using a periodic table? Because in exam you will have the periodic table. You don't have to memorize these elements as metal or non-metal. You have to just learn a simple technique. And what is this technique? First you will draw a stair between boron and aluminium. So first what we did, we draw a stair between boron and aluminium and continue this stair. So elements on the left hand side of this are metals, on the right hand side are non-metals, and in between there are few elements such as boron, silicon, germanium, arsenic, antimony, and beryllium. These are metalloid. So you just learned the metalloid, and you can simply identify metals and non-metals from the periodic table. Any question or a doubt that how you can work out the elements as a metal or a non-metal using a periodic table? Anyone having a doubt or a question, you can ask your doubt. You can use a mic or a chat if in case if you have a doubt. If you don't have, then I will move on to the next topic. So the first thing, when a periodic table is given to you, what you will do, a quick revision or repetition for this. So you will draw the stair and start between boron and aluminium. So it's easy to recognize boron and aluminum in the periodic table. On the left hand side, we have metals. On the right hand side, we have non-metals. And in between them, like boron, silicon, germanium, arsenic, antimony, these are the elements known as metalloids. And you have to learn the properties of metals and non-metals. What are the properties of metals and non-metals? Metals are strong, where non-metals are brittle. Brittle means, like example, by applying a small force, if you can break a substance, you call a brittle. Example, glass. Glass is a brittle object. Why we call glass as a brittle material or object? Because by a small force, we can break down the glass. Metals are malleable and ductile. What is the meaning of malleable and ductile? It means like you can hammer them into shape, you can make sheets, and ductile means you can use them as a wire or you can stretch them as a wire. So the term malleable means you can make sheets by hammering, and ductile means you can stretch them and make a wire by using the metal. As very common, like copper wire, aluminum wires are used because all are metals and it can be hammered into shape as well as stretched into wires. Their sonorous here refers to when you hit them hard, it produces a sound. They're good conductor of heat and electricity. So when you heat one end of the metal, the energy or heat energy can easily transfer to the other end. So they are good conductor of heat as well as electricity. They have high melting point and boiling point, except there's one exception, that is mercury. They have high density. In the last session we discussed the concept of density. Density means like how many particles or amount of matter in a unit volume. So when we say metals have high density, it means that metals have more particles in a unit space compared to that of non-metal. They can react with oxygen and form a basic oxide or metal oxide. That the type of oxide we will discuss later. About the reaction, and in reaction they form a positive ion. So how they can form a positive ion? So the general tendency of the metal is to lose electron, because if something will lose electron, it can form a positive ion. And some of them are magnetic, such as iron, whereas non-metals are brittle. By a small force you can break them. They have low melting and boiling points. They are poor conductor, except graphite or carbon, which is a good. They have low densities, less particles in a unit space. When they react with oxygen, they form an oxide, and their oxide is known as acidic oxide. And they form a negative ion. How they form a negative ion? So non-metals have a tendency to gain electron. So these are some properties of metals and non-metals. Metal tend to lose electron and form a positive ion during a reaction, whereas non-metals have a tendency to gain electron. And they react with oxygen and they tend to form oxide, which we call a basic oxide. Whereas non-metals react with oxygen, they form oxide, we call that as acidic oxide. But type of oxide, that is in chapter 8 about acid, alkali, and salt. So there we discuss in detail about the type of oxide. So you can leave this point right now. Any other point, if you're not able to understand, you can let me know. Leave point 7 and point 5 because I'm not explaining in detail now, as it will be there in acid, alkali, and salt topic. Any other point, if you're not able to understand, you can let me know. Is it clear? Then what are alloys? Describe an alloy such as brass is a mixture of metal. So when we mix two or more metals together, it will form a substance which we call alloy. Like example, first thing, when we work out, this is a staircase. So example, if I say I have magnesium and I mix magnesium with nickel, first thing what we do, we will identify the type of element. What is magnesium, metal or a non-metal? What is magnesium? Is a metal or a non-metal? So magnesium is a metal. What about nickel? Metal or a non-metal? So it is also a metal. And when we mix them together, when we mix, it's not like two metals, but if we mix two or more metals together, the combination or the mixture of the two metals, what we call that combination, we call the mixture as alloy. So basically, what is alloy? Alloy is a mixture of two or more metals. And why we prefer to use alloys rather than a pure substances? So basically what happened, the reason why we prefer to make alloys, why we want a mixture of the metal, because most of the metal which we use in our everyday life are alloys. And what is the reason for that? Because pure copper, gold, iron and aluminum, they are too soft. For like example, they can easily deform if they are very pure. Why they can easily deform? Like if I say, if this is a metal and it consists of identical atoms, so when we apply the force, the layers can easily slide over each other. These layers can easily pass over each other. So the metal will be soft. But if we mix with another element or another metal, it will become hard. Why it will become hard? As we add another element, so that element is having different size of atom, and when different size of atom, there will be a different friction between the two particles. So the layers cannot slide over each other. As the layers cannot slide over each other, then it will become hard. So if layers are identical, they can easily slide over each other. But if layers contain different types of atoms, different types of elements, because the different size of elements have different atoms have different sizes, so they cannot easily slide over each other. That's why it will become hard. So for everyday life, we do not use pure gold, iron, aluminum because they're too soft. So small amount of another element is mixed to make them hard. Like example, the gold which we use in a ornament or a jewelry, that is actually alloy of silver, copper and zinc. Same way we have a brass which is also an alloy of copper and zinc. So what alloys are doing? Alloys are harder than the pure metal. What is the reason for that? Because in a pure metals, all the ions are same size, but in alloys, the ions are different size, so they cannot slide over each other. So as you can see in the next slide, this is a structure of an alloy. So you can clearly see that because of different presence of this different size of atom, the layers will have different friction, so they cannot slide over each other. But if it was identical, if it was same type, they can easily slide over each other. Is it clear the concept of the alloys and why alloys are harder than the pure metals? Is it clear to everyone? So this is why alloys are harder, because the layers cannot slide over each other as the layers have different size of atoms. If identical type of atoms are together, like this is having identical atoms, same type of atoms, layers can easily pass over each other. But in alloys, what happened, because there's a different atoms, different size of atoms are there, so that block the layers to flow over each other. So alloys become harder compared to that of pure metals. Then in which row are substances correctly classified? What is the right answer? You can use the screen annotation. Element, compound, and mixture. You can use the screen annotation to state element. Element means, and first thing, you can find element easily in the periodic table. This is a periodic table, so you can find element in the periodic table easily. So what could be the right answer? The element, sulfur is an element. When we check compound, water is a compound. Why water is a compound? Because it's a combination of hydrogen, two hydrogen and one oxygen chemically joined. And what about brass? Brass is actually a mixture, as in the last slide we discussed. A brass is there, which is a mixture of copper and zinc. Is it clear? Anyone having a doubt in this part, which is about first we started with the definition of element, mixture, compound, and then difference between metals and non-metal. The second part, describe an alloy. What is alloy? Is a mixture of metal, and then the brass is there, which is a mixture of two metals. Any question or a doubt in this part?